Today's episode is sponsored by the new Refrigeration differential pressure monitor from WESTERMEYER Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace the filter? Wait too long to service the filter, and you could end up with nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP-01 differential pressure monitor is available now with WESTERMEYER Industries. To find out more, email sales@westermeyerind.com. Once again, that's sales@westermeyerind.com. Look for the new pressure differential monitor, available now.
Hi guys, welcome to the Advanced Refrigeration podcast. I'm your host, Kevin Compass. I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker SPORLAN and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. SPORLAN Catch-All dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the Catch-All filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the See All sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information, by downloading Bulletin 40-10 from SPORLAN.com with all the Catch-All filter dryer information. Thanks, guys. Enjoy the episode.
Good evening, everybody. Welcome to Advanced Refrigeration Podcast. We're here with your hosts, Brett Wetzel, Kevin Compass, and we have a special guest today, Brian Rogers from Danfoss. How we doing, boss?
Excellent. How about you, gentlemen?
Kevin, how was your day?
Not too bad, besides, falling off a flight of scaffolding and having a vacuum pump smash my hand and rip my fingernail off. So other than that, wasn't too bad, minus that painful morning.
Brian, you should have seen it. It was lovely. Absolutely lovely.
That sounds like a lovely day to me. Although some days I'd rather smash my hand than deal with the other stuff.
Yeah, true.
But that's all right.
Yeah. So, Brian, how long you been with Danfoss now?
Well, I've been at Danfoss for a total of 16 years now. So I started out 2005-ish. Went through the Aztec transition back to the Danfoss transition and have been there ever since. Prior to that, worked for a bunch of local refrigeration companies, actually. Not a bunch. I say a bunch. I'm only on my third job in 35 years, so I guess that's not too terrible. I've heard a lot worse stories than that, so I can't complain a whole lot. But went through the major, I'm in South Central Pennsylvania, went through the major refrigeration contractors here in the area, being Remco and Triangle Refrigeration, and then landed at Danfoss. Actually enjoyed the electronic stuff when I got into it very early on at Remco, but it was slow to take off way back then, back in the 80s. Of course, you guys were really little back then, the two of you, so.
I was born in the 80s.
Thanks, pal.
Was it were you with EIL? Was it EIL before Danfoss, or?
No, I had never actually worked for EIL or ECI. It started out as EIL, then it would transition to ECI. Then Danfoss bought ECI out and basically engulfed them into the Danfoss portfolio. But when I first started at Remco, it was EIL at that point. Then it slowly transitioned into ECI, and till the end of my tenure at Triangle Refrigeration, then it turned into Danfoss. So,
Oh, no way.
yep. So actually, Keith Bachman, I'm sure everybody's heard of that name in the training world. Keith Bachman was actually the guy that hired me 16 years ago.
And he regrets it every day.
Every single day. Well, he doesn't anymore because he's retired. So,
Yeah.
but yeah, he'll never admit that he did a decent job. At least.
You know what? I realized I got to clear out my phone contacts. The other day, I tried calling one guy who used to be an electrical engineer for Hill Phoenix, and he's like, "Brett, I've been retired for 2 years. I can't help you with that. With that number."
There's a guy like that for Square D. His name was Chuck Norman, and he retired about 4 years ago. And every once in a while, I'll still call the guy because he's told me, if you really need a question answered, call me and I'll take care of it. I said, thank you. So, but yeah, it's tougher and tougher to find a lot of the information that we need anymore. And, it's definitely not getting any easier the more technical things get. So that's a negative on some things.
Yeah. So let's talk a little bit about Danfoss, how it communicates, known issues that you've come in contact with.
All right. Well, let's start out. I don't think we need to go back any further than the 55, I would say. Or I'm sorry, the 255.
Yeah, I was going to say 255 and on.
yeah. 255. I only mentioned the 55. Honestly, I just had an issue with one the other day that I had to help straighten out. So, but the 55 and the 255 are virtually the same. Only the 255 took it a little bit further and obviously married a lot of the RC 2000 menu structure and stuff like that with the 55, and that's how they came out with the 255, which actually came out 2006, I guess, was the year that they originally came out with the first version of the 255. Early on, when they came out with the 255, it was developed to be able to, its primary communications was via modem. When we first started that in 2006, everything was still really heavily into modems. And thank God we got away from that and turned into more of a network device. But in the early days of the 255, there were two ways that we could communicate between the controllers. With the 255, you started with a 485 basically host connection where you could link several units together using a daisy chain type effect and link up to, I believe it was up to 10 because we could only do 0 to 9. So you could link up to 10 255s all together using 485. That was a fairly robust network at the time, especially when we first started out. But then as things started to develop more with the 255 and they wanted to add in the, I'm sure you guys have seen the, God, I'm drawing a name blank here. But basically where you could go to one controller, Brett, you could probably tell me the name here, virtual display, excuse me.
Oh, yeah.
Virtual display. When we went to the virtual display, you could no longer do the 485 communication because it was way too slow.
Yeah.
So that was when we developed more into the network communication between the controllers, and that's how things really started to progress with the 255. That was a really terrific tool at the time. So that kind of drove us away from the 485. Another side note on the 485 connection that we used to use to link the 255s together, we actually bought the intellectual property. Everybody thinks we bought Comtrol. We didn't really buy Comtrol. We only bought the intellectual property of Comtrol. And when we did that, we took the 255 and actually developed it to talk to the old Comtrol boards. So the only way that you could do that was through that 485 connection.
As long as the boards, the Comtrol boards are post 95, I believe.
Yeah, there's an entire criteria. You're correct, Brett. There's an entire criteria that every single board had to be a certain vintage age. And if it was older than that, we could not do it. The reason being is that the gentleman who actually worked for Comtrol and developed all that technology came to work for us. So Fred Feldman.
Oh, he got really mad the one time when I called him.
Yeah, don't call him, please. Call one of us and we'll help you through.
No, but this was like I was working on a Comtrol. I was working on a 4K. It was probably, I've been in Texas now almost 6 years. So at least 7 or 8 when I was working for AAA up in Connecticut. And I remember being at a Stop and Shop, and basically I couldn't get this freaking thing because what I did was I basically was refurbishing 6Ks to get them to communicate, and basically then had a pain in the ass time trying to get it. And he's like, "How'd you get my number? What? Why are you even calling me?"
Yeah, he can be
crass.
he can be. And even now at this point, there's times where I'll sit back and think, okay, do I really need to talk to Fred about this? And honestly, I can understand it. I can understand his thoughts on it at this point. He does so much with our MCX platform and the developing of the programming and stuff of that nature that he has no time.
I get
so, if I see him on the communicator, I will type him first. Hey, are you busy? Do you have 10 minutes or something like that before I even call him? I won't even hit his button until I ask him to make sure it's okay, because I don't want to get what you got. So, but back on the 255. So when we did the 255, we had the communications that could be basically one of two types of communications. Either we could use 485 between them, or we could use the network in between them. There are still a lot of them out there, believe it or not, that are still 485, and we're working diligently to get the people that still have those out there to try to move forward at least and get onto some type of network and allow the network to do the communications. It's still not an issue to allow them to communicate via 485. It's just slow. It's very slow. So when you dial into these locations, with the AKA 65 software, and you know how it is bouncing back and forth, it takes a long time for them to pull back compared to when you're on a network connection.
Yeah, if you have all the controllers linked up via going to a network switch, because that's how all the control overlays were done. Basically, use the 485 network as the host network, right? And then the global is basically Ethernet. I like that a lot, only because you could be at the front of the store where the manager got all his alarms, and you could bring up any rack on any controller and go through it, and it was quick as hell when it was on Ethernet. But I get why.
Yeah. And actually, the nicest part, believe it or not, the nicest part is it would disconnect itself after like 15 minutes. So you didn't have to physically go back in and say, hey, I don't want to do this virtual display anymore. When it basically went into a timeout mode, it would shut that virtual display down. So otherwise, you'd walk up to a controller and be looking at one that you're not even trying to look at. So they at least, pulled that out of their hat, I guess you could say. The 485 communications on them, though, if you do happen to find that, you're going to find that it's honestly, it's like any other network connection that it's like any other network connection. You have to daisy chain the things. We definitely we don't recommend any starring it whatsoever in any of our networks. And it's really not because the equipment won't handle a star. It's because nobody really knows how to do a star properly. You can actually use star networks, but you have to know the do's and don'ts of actually using a star. So it's so very much easier to say, don't do it, daisy chain everything. That being said,
go ahead.
Isn't the 485 basically LAN? Isn't it like the older 255 stuff? It's still LAN, right?
Yes, that's correct. So you're well. I mean, go ahead.
Yeah, I thought stars were like encouraged with Echelon.
No, they actually don't want you to do stars as much as possible, at least in the Danfoss world. You can do starring, Kevin. It can be done, but there's a very specific resistor that you have to use at the star point, and then your end of lines still come into play. So it becomes a very tricky network to build, and it's so much easier. I mean, let's face it, we all have so much on our minds. We don't need to worry about, well, do I put this resistor here? Do I do this there? It's far easier to say, daisy chain everything, put 120 at both ends, and you're done. Boom. End of story. That takes all the guesswork out of it, because there are very specific ways. Yes, you can build a star network and make it work. It's just, it's too intricate. And let's face it, we all have too much on our plates nowadays anyway to try to remember all these little intricacies. So just to make life simpler, everybody pretty much adopted the fact, hey, we're going to do a daisy chain and forget it. Also makes it, honestly, it makes it much neater when you're doing like comm loop maps and stuff like that, because there's no guesswork involved. The other thing that it really helps with more than anything is troubleshooting. Because if you have a daisy chain as opposed to a star network, I can break that thing apart anywhere and troubleshoot it to that point. Whereas if I don't know there's a star out there and I don't know it's going a different way, man, that's a whole different nightmare to troubleshoot. So definitely, I would absolutely 100% follow along with what we're saying and do everything daisy chain. What you're also going to find is on that 485 network, and I just wanted to back up to this a little bit there, Brett and Kevin, on the Comtrol networks. Whenever we did a Comtrol overlay onto the 255 or even onto the 800 as it was available on there too, we recommended that you, and this was through a very tough learning experience, and it was down in Timonium, Maryland, that we learned this the hard way. Early on, we said, hey, break that network apart, make it the way it's supposed to, do the daisy chain, put your resistors in the way that it should be, and you'll be good to go. Well, when it comes to a Comtrol network, no. Take that thing directly off of the 4K the way it was and land it on the 255 or the 800 without touching it. 90% of the time when they build a network through Comtrol, they would do what they would quote unquote call tuning. And basically, it didn't matter how they built their network. They would come to the end of it, and I actually had Fred explain this to me. They would put certain resistors on to get it to come into range so that it would read into the Comtrol. So you could end up with this nightmare network out there, which thank God there's not a lot of that crap left anymore. But you could end up with this nightmare network where you could have resistors out in different locations and not even know it. But they basically put a scope on and they would tune it and they would get it to a certain M reading and then they would tie it onto the 4K and go, yep, it's good.
Oh.
Yeah, we found that out the hard way.
I still see a lot of Comtrol, unfortunately.
Well, let's hope that goes by the wayside. I mean, it's been how many years since we bought the Comtrol, properties? It's at least 5 years at this point, if not longer. So, unfortunately, yeah, you're correct. There's a lot of it usually turns out to be independents or smaller chains where that stuff just sticks around and just stays and stays and stays until they finally can't get the parts anymore and have to do away with it and remove it.
Kevin,
unfortunately, this chain did a massive amount of overlays and then a massive amount of they did a massive amount of Danfoss change outs. So now they have just boxes and boxes and boxes of boards and controllers. So hopefully it starts going away soon.
Yeah. Well, I hope that for you. How's that?
Yeah.
Okay. So go ahead.
Go ahead.
I'm sorry, I was just going to jump back on there. So on the 255s and even the 55s and the 800s, you had the 485 network as well as the TP78 network. So the 485 network that we used on the 255, like I said, it was the main purpose was for it to communicate between the 255s. As it pertained to the 255, there were no resistors built in line, so you physically had to put an end-of-a-line resistor at both ends. So no matter how you built that network, you wanted to make sure you had 120 ohm resistor on both ends of that network, and then it was a complete network. When it comes to troubleshooting like that 485 network, it really becomes very simple because you're honestly looking for continuity. I mean, on the 485 network that we had for a host network on there, if you had good continuity going from controller to controller, you didn't have a broken wire, and you had your resistors in place, it was a very tight, tough network. It was really tough to break. And even if you had like a dead 255 in the middle, it never really seemed to draw that particular network down. The 485 host network was always pretty good in that aspect. Now, when you get into, say, the Comtrol network or what have you, that you would have troubleshooting on, That's going to be, honestly, it would be just like troubleshooting our TP78 network, which we're going to, I guess, pretty much hop into now. So on the bottom of the 255 and the 800, the 800 version that had the TP78 capability, we had various network points on the bottom of it. The 255 would have five loops of TP78 coming off of it, and the 800 would have 4. Off the bottom of that, we built resistors into the boards on the 255 because we knew where the beginning of the network was going to be. So that eliminated you from placing one of the resistors on, because you always knew where that was going to be. Now on the 800, we actually put a termination resistor on a toggle switch on the 800. And the reason being is, as we moved forward, in like every other company, as we moved forward and we kind of learned the life lessons of dealing with networks and things of that nature, you can put the 800 in the middle of a network loop. So you would actually end up with 2 legs going each way. And in that case, you would turn that termination resistor off and add a resistor at both physical ends of the wiring. Now, if you were to start a loop at the 800, you just simply turn on that resistor, and there's your 120 ohm, and then you would put your 120 out at the other end of it. But you did have the capability of taking that TP78 loop and actually splitting it and having the 800 reside in the center of it. The 255 you could not do that with, because we had no way to turn that resistor off. That resistor is actually soldered straight to the board. There's no ifs, ands, or buts about it. That has to be the beginning of the loop. So it actually, as we moved into the 800, we actually gave you a little bit more leeway in the ability to add more loops if you wanted to. The biggest suggestion that comes to mind right off the bat with these TP78 loops, and it may sound like a tremendous pain in the ass as you're trying to build this, but we gave you a number of loops on there kind of for a reason. And the biggest reason is troubleshooting. So if you divide your store up, say you have a typical TP78 store, and this could be either a 255 or an 800, and just say we had the 255 with 5 loops on there. If you utilize one loop to do the entire store, something goes down on that loop, you've got to troubleshoot the entire store. I mean, you've got to go from beginning to end. And unfortunately, with TP78, there's no easy way. There's no voltage check. There's nothing like that to really assist you in doing it. If you're actually looking for a network error, you're going to break this thing apart basically and kind of go by a continuity type thing. First and foremost, you want to check and make sure that you do have a complete network going out and back. So you're gonna work, and hopefully somebody was nice enough to let you a comm loop map or something of that nature. Yeah, it doesn't always happen, but still, it was possible.
As-builts don't exist anymore, I don't think. Yeah, I think they're an afterthought. Unfortunately, it makes it so much easier.
It does.
As the last electrician told me, as-builts are just a suggestion.
Correct. Well, unfortunately, it makes our lives a lot harder, because then you physically need to trace out where the wiring goes. So that being said, if I take these 5 loops and I break them down into common sense loops and say, okay, I want loop number 1, I want that to include everything on the rack. I want loop number 2 to go to the condenser. I want loop number 3 maybe to go over to the defrost panel, and then loop number 4 goes wherever it happens to go. So simply by breaking those down like that, if I have a TP78 failure, I can go right to the unit and start unplugging plugs and go down to one plug and go, okay, did that come online? Do a rescan, and hey, I've got the entire rack online. Okay, so I know it's not in that comm loop. Go ahead, Brett.
So I have a question. So if you have, you said there's 5 different possible comm loops that you have, right? So yes. Have you ever had where one system that was shorting out, whether it be an analog input on a case controller, basically pulling down that network so bad that it basically takes out the rest of the comm loops, or will it basically act like an isolator and basically isolate that one loop from the rest, so you're not going to drop the whole store?
The more typical, and I can't say that I've never seen it, Brett, but none of them are coming to mind. But the more typical is it's going to wipe out that particular loop only.
Okay.
It would almost have to be a dead short right near the 255 or 800 to kind of wipe out the whole thing. and I have not seen that yet. That not that I can remember off the top of my head anyway.
I'm just asking because Novar, they are, I'm sorry, CPC, on some of the older older Emerson controllers, they had the control link, basically, because they were on a repeater, they're basically still all linked internally. So I didn't know if it would go back, but when this happened, when this shorted out, because it was a direct short, basically it took out every single controller, and that's what happened there. So, basically, I didn't know if, in that instance, because it's on the repeater, is that why it took down the whole network versus, your single ports?
Yeah, see, when you incorporate a repeater like that, and we do suggest that over X amount of feet too, and it used to be 5,000 feet on the 255s and like 4,000 feet on the 800s, and if you extended past that, then you were supposed to add a repeater in there. And I've seen TP78 repeaters. Well, what happens is when you install a repeater like that, it basically funnels everything down to that one point. Mm-hmm. So yeah, if you have something on the other side of that repeater that dumps out, it could take out the entire network, depending on whether that was the only loop coming back or not. And now it's affected that repeater and took it all out. But the odds are on a multi-tap like we have, where you either have five or four different ports on there, usually it does not wipe out the whole TP78 network. And it's weird. You'll see it because, in fact, there was just a store, Walmart, that one of the guys was at the other day where he had the same type of thing happen. He was all rooftop units and the old RTC boards. And one way on the loop it took out and the other way it didn't. Well, it was kind of nice that they had it split up that way because he was able to unhook one side of the wiring. But there were dead RTCs on there that were drawing that half of the loop down. So it typically does not take the whole thing down. That's usually not a typical thing that happens. I'm not saying it's impossible, because anything, as you know, is possible. So never say that anything isn't possible. But the odds are you're only going to wipe out that one particular comp loop.
So I had another question. When dealing with, you said you were talking about continuity, making sure you had good continuity. From my understanding, just correct me if anything I'm saying is wrong, but like basically what you would do is start from the one end of the comm loop and basically pull every single Molex plug off. So you basically have everything there. Then at that point, you can measure from, negative to shield and positive to shield and see if you have any continuity, see if you have any pinches or anything. Then basically what you do is basically go to the end of the loop, tie everything together, and then make sure that you basically have even resistance. So if you have 50 on this side, 50 on this side, then you know that you have no loose connections or any kind of frays and stuff, right?
Well, what I would do is stop at the point where you've already disconnected everything, and you should have an end of loop or an end of line resistor on your very last node out there.
True.
So if you test it, you should have 120 ohms.
True. Yeah.
So honestly, that gives you your continuity check all in one big whack, and that's where you start plugging things back in. And typically when I tell guys to troubleshoot, I start them at, okay, first off, hook up the one closest to the T55. I want to eliminate the fact that there's anything possibly wrong with that echelon chip inside the unit. So I hook up the very closest one to it, do a scan. Did it come online? Yep. No. Get your answer. If it's yes, obviously the communications is working. So then you can take a next leap, and you don't have to go one at a time. You can add, say we're dealing with case controllers and you got this whole loop going out through the store with 50 case controllers. Okay, go tie 5 of them on, or tie 10 of them on. Do a rescan. Did those 10 come on? It's simple yes or no. If they came on, okay, move on to the next 10. Sooner or later, you're going to find a point where it goes boom, and it wipes the whole thing out.
Okay.
That's when you got to back up and say, okay. And that's why we say, don't do the whole store at one time. Bring a couple on at a time. Even at 10, okay, so I brought those last 10 in and all of a sudden it crapped out. Okay, I'm going to take 5 of those last 10 off, rescan it, then I come back online. If I did, okay, I know it's in those last 5 that I tied in where I've got an issue. So I can go one by one until I find the one that really dumps it out. Or if it didn't come back online, okay, I back up 5 more and I had a good spot there, and then I start adding one by one. Unfortunately, there is I wish I could say that there's a magic bullet that you could just pull the trigger and go, hey, there it is. That's the one that's bad. But we all know that that's not a very realistic possibility.
Unless it's blinking that pretty red color, right?
Yeah. Yeah, if you got a comm module that's blinking that lovely red color, that's where you would go first. But like on case controllers where you don't have that red, you don't have that red light, basically, it really becomes a very methodical is the term to use, and that's the only thing you can really do. And we've done this with stores with 110 case controllers on. Yes, it takes time. Yes, it's a pain in the ass, but it's the surefire way to find out what you're going to get.
Yeah.
And if you, and that's why I mentioned earlier about breaking these loops down. If I break those loops down, okay, say I've got 100 case controllers in a store. If I put them all in one loop, I got to bang all 100 of them out, and go from there. If I divide that into 4 loops, I can unplug all those 4 loops and plug 4 up, plug those 1 plugs in at a time and take it down to a 25% chance right off the bat. That's much quicker. So, for troubleshooting wise, it just makes more sense to go ahead and use the ports that are available. Some companies go, we won't use all 5. We're only going to use 4. Okay, that's fine. Just break it down some way to make it easier on your technicians. That's the bottom line.
So
go ahead, Brett.
With a TP78 network, I was in for any kind of like echelon type network. You can use an oscilloscope to actually check the network, correct?
That's where I was going next. So
sorry.
That's all right, because we had talked about this, you and I.
No, I just don't want to forget that there was all this good stuff. No. I don't want to forget.
So we use an oscilloscope. Us field guys that are still doing some of this. It is called a picoscope, and actually it's a scope that you can get that ties onto your laptop, and it's basically a USB oscilloscope. It uses the screen off your laptop, but it's got all the electronics built in. It's not a real expensive. It's probably only $300 or $400 for the thing and the probes, but it's good enough to find out whether you've got noise on the line. And basically, anytime you're using an oscilloscope, what I'm looking for with that scope is looking to see whether I got noise. Okay, did somebody screw up and lay this comm loop across ballasts or 480 or something like that? They didn't shield it right. They didn't ground the shield. They didn't use shielded cable whatsoever. That's biggies. And those are fairly common things. If you look around, you'll get an idea as you open up these panels, whether you've got a shield even on the cable or not. That's probably the first and foremost thing to look at. So, as you start doing some of this and you get more and more used to it, the oscilloscope honestly probably falls as one of the last things to look at, because I got to tell you, 80 to 85% of it is going to be unshielded wire. I've got a pinched wire. I've got something shorted, something very simple. And I hate to say that because that's what it really boils down to. And honestly, when you look at a lot of the refrigeration issues that you have in a grocery store today, so many times the technicians go in looking for that big kill. They're going, we're going in to find this. And you find out it's a fan motor that's out, or the power head's bad on the expansion valve. It's no big kill, but how it is. You go in with this mentality, troubleshooting in the van. The same thing happens when you're doing electronics. You start troubleshooting that in the van, you're going to miss it by a long shot. I guarantee you.
So I got some texts like that where, they basically look for the biggest, most messed up thing, and I'm like, keep it simple, stupid. Just start from the basics and go back further. Because otherwise you're looking for this craziness when the whole time it was just valve was blocked. You know what I mean? Oh, the piping's off and this, and they start going engineering brain on it. You know what I mean? Trying to fix it.
Yeah. There's no doubt. Go ahead, Kevin.
So I have a question about the shielded cable. So is that only you guys thing? Because most lawn work stuff, it seems like it's non-shielded cable. Like for example, like microthermal and like some other lawn stuff. It seems like it's mostly unshielded cable.
So I guess a long time ago, Danfoss decided they were going to use shielded cable, and this even goes back to the NC25, which was before the 55 even. I think what we decided was just we wanted to be extra safe on what we were doing. We didn't want a whole lot of drifting going on. We picked shielded cable for the sole purpose of making this thing more solid, more stable. And I think where you see the big differences is especially temperature probes. If you watch people's temperature probes, you can look at that and pretty much tell very quickly whether they use shielded or unshielded cable, because you can sit there and watch that temperature probe go boop, 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 boop. You know damn well the temperature's not changing that quick, so you're watching basically noise come across that line. Well, noise to a computer system pretty much wreaks havoc. I mean, let's face it. Any noise that I get on that communications line is going to affect it in some way, shape, or form. So if I can put a shielded cable in and try to eliminate all of that background noise or that induced voltage or whatever it happens to be that's causing that, the better I'm going to be. The tighter the network, the more concise the information is going to be. It's going to really make it a lot better for the whole thing in general. I'm not saying that it's bad not to use shielded cable, but with our system, it's you need to do it. I've seen it way too many times, where they'll slap a section of cable in and not even think about it. And I can show you the noise that it created on the network. And now all of a sudden we have a problem with, communications. We're losing this, or this is dropping offline. And you go and swap out that simple piece of wire and watch it all disappear.
What should the wave actually look like? Like, is it a straight up sine wave? Is it a square wave? What's, basically the height and width?
So really, I won't, to get into the technicalities of the height and width is really not that important, Brett. To be honest with you, what I'm looking for is a nice square wave on the very top and the very bottom of that wave. Well, the top more than the bottom. You will see some very small, like little jaggedness. Okay. Not a lot, but enough. What's happening is when that wave goes up, that's an initiation of the communications. The little jumping in the top of it is the actual communications, and then it drops off.
Okay.
So I want a nice square pattern, and I don't want at the top. I don't want to see, a heartbeat.
Really jagged.
I want to see just a very little. Just a very little, modulation basically in the top of that flat peak. Anything that I see any different than that is going to be an introduction of noise. And how far you go, it honestly depends. I mean, if you're talking about short runs and stuff like that, you can actually introduce a little bit more noise and get away with it.
Yeah.
But if you're talking about, I've got all 5,000 feet of it out there, and now all of a sudden I've got noise in there, it may not need to be a lot of noise, but it's going to be amplified basically because of all the transmissions that I'm trying to get through that line. And the more case controllers and things that I put in there, where I'm constantly transmitting back and forth on there, any little blip is going to cause a big problem in that information being passed back and forth.
I had a garbage compactor that was causing interference. The motor, the three-phase motor on the compactor was, because of the way the comm line was ran, it was ran up right against the wall, which is right near, where all that stuff is on the top of the compactor. And basically, because we couldn't find any rhyme or reason, right? There was no exact time. It was random all the time where it would just drop it. And basically the three-phase induced, motor on there just basically just kept taking out the comm loop whenever they would press it. And we found it by accident.
Yeah. We had, it was an Air Force base. I think it was F.E. Warren Air Force Base out in Cheyenne, Washington, where the communications were that terrible out there. They sent me out to meet with the installing contractor out there, and I threw the oscilloscope on, and it basically looked like seismic activity that I was looking at on this. There was no other way to describe it other than the fact that it looked like seismic activity, like you'd see the needle jump during an earthquake. It was that bad. And I looked at this guy and I said, did you guys run the right wire? And I've got the guy standing there that pulled the wire physically. He goes, here's the wire we used.
Romex cable.
That was doorbell wire. No.
8 pair.
What we came to find out is they used all like 277 lighting in this building, and they had the comm loops ran first. And the electricians, when they were running this stuff, they just lay it across the conduit or lay it across the comm wires and stuff and not really think too much about it. And just by them going out through and following the comm loops and separating that, they were able to get that communications back, where it was better. It was definitely not 100%, but it was enough that they weren't dropping things offline. So, I mean, you never know what you're going to find. You get all that communications work done, and all of a sudden it decides it's going to dump out. It could be anything. I mean, somebody could have pinched a line. You could very simply have, 480 or 460 is the absolute worst to lay across it. And honestly, what's worse is if it runs parallel with it. If it crosses it, its exposure is much less. But if you're running parallel, and they even found some where they strapped it on the same conduit where we had our wires strapped to it, it's like, come on, guys, you can't do it. Use your head a little bit.
Yeah, that's what I was told. As long as you go basically crossing it, because if you do, basically, you have, the what do I want to call it? Basically, the magnetic, the inductive
electromagnetic field. Yep.
And it's basically hitting, going in phase with the wires and basically causing all that noise.
Yeah. So if you do have to cross a comm wire, you want to cross it perpendicular. You don't want to go straight across. Don't lay it alongside. Don't lay it with it or anything like that, because it's like a longer exposure is what it boils down to.
Yeah, and sometimes when you're doing a startup on a rack and you're making all the connections, I mean, it's tough because a lot of the comm stuff is right next to all the 460 stuff. They really don't separate it all that much.
They don't. And the best thing you can do there is try to keep it on the outside of the panel until you get it to where you want it, and then poke a hole, which is a pain in the butt too, because you got to drill your own hole then. But in the aspect of getting a nice clean install, sometimes it takes a little bit of a pain in the ass to make it happen a little bit better, just to keep it away from that 460. Contactors absolutely suck too. Every time a contactor slaps in, you can actually sit there and watch a spike on that oscilloscope. And that's just inside the rack. I mean, so if you can keep it away from the contactors and then poke it in somewhere where it's not near them, but just laying it along the bottom like all the rack manufacturers do, they'll lay the wiring along the bottom and stuff like that. You're going to pick it up. There's no ifs, ands, or buts. One of the worst things that I found, believe it or not, when you're looking at communications and issues like that is HVAC units. So, the HVAC, the rooftop units, basically. So you get up there, and first and foremost, you get these guys that are, I'm sorry to say this, but you get these guys that are lazy, and they don't want to spend the extra money to put the little Danfoss transformer in, because it's $50-some. We could cut that cost, and we're just going to use the 24 volts out of the HVAC unit to power up that board. That's terrific. But let me tell you, there's a reason that we tell you to use our transformer. It's got noise isolation built in it. And I can show you HVAC units where you can watch the temperatures jump anywhere from 10 to 15 degrees in seconds. And it's simply because of that noise issue. Every time the contactor pulls in to pull the compressor on, the temperature jumps 15 degrees, and they're going, why can't we hold this temperature steady in this area? Where'd you get your power? So it's, those are the things that you run into all over the place. So they're fairly common. Go ahead.
No, I was going to say I've used, I actually really like the smaller module ones, the DIN rail mounted power supplies, only because they're adjustable. You can adjust them, and the input voltage is anywhere from 120 all the way up to 240. And so, you can basically input any voltage and still get that 24 volts out. And there's an adjustment screw on there, so you can actually tweak it a little bit to compensate for voltages.
Yeah, most definitely.
Nice. When I build panels, I use those things all the time, because those things they're nice, they're small, and they hold their voltage really good.
Yeah, that was one of our better ideas. I honestly, I just found out that there's a third size. I never knew there was a third size. So you've got the one that's the same width as a comm module, which you guys have all seen, and I forget what the VA is on that one. Then you've got the little half size one, which fits in these boxes nicely to give you enough at least for one lineup of modules. And they built one in between, which I've never used. But apparently there's a number for it, and I don't know what it is off the top of my head.
No, what I was going to ask is how many, can we now do 15 modules in a row? We just need a real long freaking panel, and with that bigger power supply, or what? How many modules will that take?
The middle size one you're talking about, yeah. I think it'll do a lineup of 9 modules altogether.
Okay.
So it'll do one row of 9. Go ahead.
Brian, do you guys make a 460 Volt 1 or rooftops. Like, I mean, that seems to be the big problem with all these rooftops. You end up with a 460, the 24 volt transformer, and that's where the issue comes in.
It is a very well-known issue. Yes, we do not make a 460 transformer like that, which I would love to see them do. I don't know that they will do it because you can very easily get a step-down transformer to put on there, and it doesn't have to be a big one, you know. And that part doesn't have to be expensive. I think for us to build a 460 transformer would probably be more expensive than putting the freaking step-down on it and be done with it.
True.
I don't know. That's just a guess, Kevin. I don't often see the dollars and cents of it. I'm more of the, you know, hey, let's get this done. But I agree with you. I mean, I'd love to see. I couldn't tell you how many times I've seen a guy take like a 460 volt condenser and go, "Hey man, I tied your transformer in and the thing smoked. You know what voltage you got there? 460? Yeah, we don't do 460.
Well, it's 277 to ground, so I'm close to that 240 mark, so I should be straight, right?
Yeah. It's close enough. That's one of those close doesn't count deals. Yeah.
No, close enough for government work. That's usually what it is, right?
Yeah. And unfortunately, we do not sell smoke kits. So we'd have no way to put the smoke back inside those devices. Once it's released, it's released. All you can do is, you know, throw it out and get a new one.
Hey guys, I want to take a break and talk about WESTERMEYER, one of our other sponsors. Today's episode is sponsored by WESTERMEYER Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry. Gotcha.
But yeah, I mean, so on the TP78 networks and even the 485 networks, yes, you can use an oscilloscope. There's no specific, you know, we're not really looking for a voltage range or anything like that. I'm really just looking to see what that wave looks like, what that wave, you know, that square wave should exist there. That even goes into the Modbus that we're using now too. Now they will tell you that there's some Modbus voltages. I believe the voltage range is up to 5 volts DC is what you can see on a Modbus. But to be quite honest with you, I'm not as concerned with the voltage on that Modbus loop as I am that sine wave. And strictly because it's more of an indication of what's happening with my information. The voltage range that I would happen to fall in is not nearly as important to me as what that sine wave is doing.
So is Modbus then a regular sine wave instead of a square wave then?
No, it'll still hold the square wave, bro.
Okay.
It'll still look the same as that because again, it is sending that information out at the peak. Now it won't be nearly as wide as it is on the TP78. It happens a little bit quicker, but of course you can always adjust your scope to see the width a little bit wider. And again, I'm looking for that more of a very fine jaggedness at the top compared to that, you know, sharp up and down.
Same ohm resistor for the beginning and the end?
Yeah, same ohm resistor. Everything stays 120. We wanted to make sure that none of that, you know, changed. We obviously still tell you daisy chain all that too. We don't have any issues with that. The only difference is that will be a different wire because it has to be an EIS 485 compliant wire. Typically we suggest a Windy City wire, and there's numbers published, you know, of what wire number that should be.
Yeah.
And it boils down to the wires that we recommend that you use on these. You know, we've done a lot of research to make sure that it fits into the nomenclature. It's got to have a certain impedance, which, you know, goes into that ohm reading and such. It also has to have a certain amount of twists per foot, and that all affects it. And the shielding has to be a certain way. And that's why we kind of get not anal about these numbers, but, you know, if we don't see that specific, it opens the door for possibilities of causing trouble. You know, so if you don't follow them, I'm not saying by all means that you have to go out and buy Windy City's wire, but you want to follow that same spec and don't look at it and go, well, this one's 110 and this one's 130, but that's close enough. No, it's not close enough. We wanted the 110. That's why we gave you that specific number. So it should match all of the characteristics of that particular number. And there is a publication out. Let's see what this is even called. I printed it out, Brett, because I really didn't want to look real stupid on this call. so I wanted to have all this information. You think I'm kidding? Right there it is, buddy. I made sure I had it right in front of me. but it's called Data Communication Between Adapt Cool Refrigeration Controls. And I know it's out there on the internet because I Googled it and got it. But there's a listing in there, honestly, of basically all the wires that we suggest, and it spells out, like, for a TP78 LAN network, I want this specific wire. For a Modbus network, I want this specific wire, and it gives you more than one. It's not just saying, hey, we only want to sell Belden, so we're only going to give you the Belden number. We don't do that. We don't really play favorites. We just want it to fit that nomenclature. And I know sometimes, when Danfoss comes across and they tell you certain things like that, and this goes back to when I was out in the field too, because I would think, boy, these guys are real asses. They're telling me it's got to be this, and it's got to be that. You can take it like that if you want to, but there's definitely a reason we're doing it. And if there's a doubt of why we're doing it, call me up next time you're troubleshooting a comm loop that you can't figure out and it's got the wrong wire on. And after you've wasted about 2 weeks going through all this wiring, and a Danfoss tech comes to you and goes, well, that's the wrong wire. It'll never work with that. And you swap out the first piece and everything comes online and you go, son of a bitch. That's why we tell you what these numbers are, because we've done it. We've made all the mistakes to look at you and go, hey, this is why we're telling you we want this wire. Yeah. I mean, one of the things that I deal with, I personally deal with the Kroger chain across the entire United States. And one of the things when I'm doing their kickoff meetings at the beginning of every one of their jobs is I tell them, first and foremost, when you're doing the comm loops into these case controllers, which they use all, case controllers in their stores. When you're doing your comm loops into these case controllers, don't send out your rookie to make these connections. Send your best guy. And they look at you and go, well, why would I take my best guy to go out there and hook up these little comm loops with this stupid little 22 and 24 gauge wire? And I said, well, I'm going to tell you right now, because I personally was out on a store in Georgia that it took them 2 weeks to go through every single connection and find all the hairs that were crossed over, because they sent the rookie out to connect this comm loop up in the store. And it took them 2 weeks to go through and find all the crap, basically, that tore this comm loop down. And they paid the first guy to go out and do it. Then they paid their best guy to go out and run through it again. All they had to do was pay him the first time and they wouldn't have had the problem.
Agreed.
So a lot of times we make suggestions, and it's not us trying to be asses about it or anything like that. We're trying to save you guys in the long run of having to deal with it. Because, I mean, let's face it, Brett, or even Kevin, you get your rookie out there. It's great. He wants to go out there and make those connections. Sure, he's doing his job, but he doesn't know. He doesn't know that if I cross one hair over there, that it could be detrimental to the whole thing. Okay, well, now he's done that on 120 case controllers. I've got a major problem. Or let's say, he's pulling wire for you and he goes, shit, I'm out of this, but here's this piece of, there's the burglar alarm wire. That's red. I can use that. And he runs that in there, and now all of a sudden the comm loop doesn't work because I've induced noise into it. Yeah. There's a reason, like I said, we're not out there trying to be jerks and saying this is the way everything has to be. There's a reason we're telling you that's how it's got to be.
There's a lot of stuff that the Danfoss controllers can actually interface with, and I'm sure with the 800 and the new 850 coming out, 850A, right?
880A, well, 800A, 800A will cover it, yeah.
But basically, I know you guys can communicate with some BAC stuff. What other controllers can you guys communicate with?
So right now, what we're working on, we're actually we have been developing a backnet solution, which will allow us to tie into specific backnet devices. Sorry, my English is a little rough, I guess, this evening. Or maybe I didn't have enough bourbon yet, but we'll fix that. At this point, the stuff that we are approved to tie into are going to be Linux units. We do have a specific range of Munters units that we can tie into and talk to. We have some energy meters that we directly talk to from Varus. And all of that stuff has slowly been developing. There are Modbus devices that we have capabilities to talk to at this particular point. But I think what you're going to see grow going into the future is the BACnet stuff, where it's allowing us to tie into devices where we weren't never tying it into it before.
Like drives?
Actually, it would have to be a competitor's drive, to be honest with you, to run it in BACnet, because, the Danfoss drives, we talked to them on either TP78 or 485 at this point,
okay.
And we always have. So we've actually had a communications card that would actually work with our own stuff. The BACnet is the new thing that we're starting to open up and develop, and it's a slow process, but because we don't want to jump in and look like fools, basically. So we want to go very slowly and very methodically. And when we're done with it, we're going to say it's done and it's right. So, those things are slow in developing. And unfortunately, that's the nature of the beast. But there's so many things that we can, through Modbus that we already have the capability. I mean, there's different stats and things like that. The energy meters were a big one. The MCX devices, which is kind of our device anyway. So there's a lot of stuff that going through that Modbus network that we can already tie to and talk to, which has really opened up our portfolio from the TP78 days. Once we developed that Modbus capability, it gave us the ability, different pack controllers and different rack controllers and things that not everybody here in the United States sees that they were using in Europe. Now we can bring them over here and actually utilize the pack controllers and stuff, which we were typically only using on CO2 racks. But now that opens it up to actually control, standard HFC racks and stuff like that. One of the things that they're looking at while they're doing this, and even the case controllers came from Europe and were developed under the Modbus networking type stuff. But one of the things that Danfoss has been trying to continue to move forward to is this distributed control solution, where you basically don't have all your eggs in one basket. So, you've got standalone case controllers. Okay, if I lose communications to it, the case controller still keeps doing its thing. I've got HVAC controllers that the HVAC units, if I lose communications, they still run and they still do their things. The pack controller is the same thing. I can lose communications to it. So the 800 truly becomes what it was designed to be, a system manager. It's no longer like a controller anymore. It's basically a system manager that is responsible for just communicating alarms and information all over the place and allow these individual devices to do their own work, basically.
Kevin, I got two questions for you. How much Danfoss do you guys have up like in that Chicago area?
How much Danfoss do we see?
Yeah.
A lot. We have a chain up here where we see quite a bit. Probably, it's an Albertsons chain, so I mean probably half of their stores out of maybe 70 stores out of 120, 130 are all Danfoss. So I've done a couple 880 changeovers or 800 controllers, so I'm still kind of getting into it. But other than that, I don't have any Danfoss besides those stores.
The other question I had is, how the hell does Brian have better internet service than you living in Amish country and your shit keeps cutting in and out?
Dude, this has been by far the worst. I don't know what's going on here. Like the Wi-Fi's down right next to me, so the Wi-Fi in my truck isn't working, and
Brian gets stuck behind horse and buggy. Like that's where he lives.
I mean, literally, there's a horse out there right now on a treadmill generating power for me to even keep this going, and I still have better internet.
I mean, I'm not far off from Amish country, but like, I don't know. Like, and what really sucks is like they built this giant $1 million subdivision in front of us, and they have fiber, and it's like literally like less than 700 feet from my house,
and you can't get it.
And they won't bring it in here.
I told you, start digging.
Just tap into the neighbor, yeah.
It's painful. Trust me, when I'm dialing into stores, some days it is painful, depending on what I'm doing. If I got to get in a VPN, it takes me forever.
So, Brian, you were talking about the 255, then we jumped right to the 800. Now, I know there was another controller in between. I believe it was 355, and that was set up predominantly for CO2 application, like booster racks and that, right?
It was actually developed more for the Safeway chain years ago for them to transition from Comtrol into the Danfoss realm, and they wanted to have a greater capability of being able to do stuff like they could on the what was that Niagara system, the Chrysalis, the you know what I'm talking about, Brett, the Comtrol C-Web stuff.
Yes, the little box with the little segmented lights on there.
Yeah,
It's screwed up all the way up here.
Yeah, exactly. So they wanted to develop into a different type of setup, and the 355. I'll try to run through this basically pretty quickly. So 255 was developed strictly by Danfoss, obviously, but it was developed using our own software. We could do anything we want with it. We didn't have to follow any Windows guidelines or anything whatsoever. We could build it the way we want it and make it happen that way. Then the customers decided they wanted to be able to do this type of reporting. They wanted to be able to get this type of information. They wanted dashboards. They wanted, all these different widgets and stuff for reporting and stuff like that. So Danfoss had to transition to a Windows-based device. That was the birth of the 355. So the 355 was the early 800. To be honest with you, okay. They pushed and pushed and pushed to develop the 355 very rapidly. It used the hardware of the 255, but it used the software basically that we're seeing in the 800 now. Okay. Well, not now, but the original 800. So it was kind of a hybrid to get us to the 800. It was very short-lived in length of time, and it was always kind of designed to be that way because we knew the 800 was following right behind it, but we were being very pushed to get this thing out there to market so that chain could use it and utilize changing this era. This was about the same time that Comtrol was kind of dropping out of business, and we were, that was their solution. They wanted us to develop this for them, so we did. So it was early on that we developed that 355, and it was kind of a niche piece, to get us through. Then we jumped over to the 800. Well, let me tell you, when the technicians saw the 800, it was not a very warm welcome. There's no two ways about that. And a lot of that has to do with the fact that when we built it and we did the original programming for it, we had to stick with the Windows way of doing life. And that was because it was customer driven. That's what they wanted out of it. So in order for us to build it and have it operate that way, we had to kind of stick to Windows protocols, and that's how it got developed. So the technicians found that, hey, this is a little more difficult. This isn't quite as user friendly. All those things you're not going to get me to disagree with. It's absolutely true. But it was because of the constraints that we were held to, that how we had to develop it that made it tougher on everybody. Along those lines, though, we did incorporate a lot of kind of newer information and newer ways of doing things. Like originally to do a 255 to 800 changeover, I don't know a whole lot of companies that had a conversion program actually built into the controller. So you could take a program out of a 255 at a certain software level and physically drop it into the 800, and it would rewrite the program for you.
Oh, wow.
And you had to have it at 2.231, and your controller, your 800 controller, I believe, had to be at 8053 or higher or something like that on the original 800s. And it would automatically rewrite the program. And if it found anything that did not fit into the new Windows-based layout, there was a tab that said information, and you could go in there and it would list out anything that it could not fit into the new platform.
So something you'd have to rebuild from that controller from scratch then, yeah?
Yeah. I mean, so let's say, for instance, and this is just an example. I don't think this is necessarily true, but say the 800 did not have the capability to raise the head pressure up when you went into heat reclaim to give you more heat or something like that. Yeah. It would come up and say that on there, hey, we did not have this capability. We couldn't convert it. So here's this strategy that you need to find a way to make it happen differently.
Calculation.
Yeah, exactly. So it would write the rest of the program and all that was fine and dandy, but it would pick out these little one-liner things that it couldn't fit into the platform, and it would tell you that it was there. So, that kind of made life easier. Well, what we discovered then is guys not liking the layout of the 800, they'd write the program in 255 and just dump it into an 800. So instead of having to write it in the 800 platform, they would write it in the 255, dump it in, and they'd be good to go. So they learned ways around to save time, rather than writing it directly into the 800.
Hey, speaking of calculations, how comes there's not is there? Well, I'm sorry, maybe I'm wrong. Is there a guide that actually shows you how to write them, like basic information?
So there are, first and foremost, on YouTube, you're going to find a whole Danfoss channel. And I know that one of those on there is on how it's an educational platform on how to write calculations. There is no, as far as I know, there's no written booklet that says, here's how you write a calculation. And I think the reason for that, to be honest with you, Brett, is because there is no right or wrong to it. There's no clear-cut designing of a calculation.
No, I get it, but the problem comes where you have technicians that want to basically understand, right? But they don't understand the Boolean logic of it, right? The greater, the ands, ors, the NOR gates, stuff like that, right?
Yeah, and I like I said, I know that and now Keith had when he was given the training, and the new guy that you'll be getting a hold of, his name is Ernie. I know you've talked to him or Dave Yoder already, but I know that they have during their typical training class or their certification class, they do go through a section on writing calculations, and they actually make you write out a specific calculation to a certain set of parameters. But here's the issue, the big issue with calculations. There's three guys that are sitting here right now talking on this broadcast. I can write a calculation one way, Brett, and make it work. You could write another calculation that does the same thing and it looks completely different, and Kevin can find a third way to write that calculation, and all three of them are right. That's the biggest part about calculations. There's so much gray area. How do you teach the gray area? You can teach the basics, which you'll find on that YouTube thing on how to write calculations and kind of giving you an idea. But really, until you have you almost need to say, here's what I want it to do. How can we do it? And then walk through it with either a Danfoss guy or someone who knows calculations. I'm assuming at this point, Brett, you've written enough calculations, you ought to be able to figure it out.
Well, I'm just saying for anyone else.
For the average guy, yes. They're going to have to talk to somebody at some point to get an understanding of how those are, or get on and watch that. And I haven't watched the video myself. I can't tell you how good it is or anything like that. I do know in the class that they give, when Keith was doing it, he would give you a very specific problem that had to be solved in calculations. And you would basically have to write 2 or 3 calculations to make the whole thing work the way that he wanted to. And what it did was it made you think about, how would I go about it? What points would I use? What logic do I need to involve in there? And before that, he would walk through some of the basic logic of what an if or, what the and equals, what the greater and less than, and what that stuff does. And the biggest thing that everybody kind of misses at the end of almost every logic statement that's supposed to do something is the last statement should be basically a statement that turns the logic back the other way. Otherwise, it's a latch. And you basically have to, because it'll say down at the bottom of the logic statement when you're building the actual logic, it'll say the first true line makes it happen. So if all of them are false and you don't have a true line, it'll never come out of that logic statement. So the very last thing that most logic statements have to have is just a very simple statement that says true equals this. So that would be the last true line that would take and flip the logic back the opposite direction. And those are the biggest things that are hard to communicate. I'm not saying they're impossible, Brett, but it takes a lot of time to understand a logic statement. And then if you have a guy that's good at them, like you guys have written them for years, I've written them for a long time, I can make logic statements that are absolutely insane for somebody to understand. And that's not the goal. What I try to do at this point, being later on in this, is I try to make them, like you say, keep them as simple, stupid as I can, so that any Joe Blow can walk in and go, hey, he's trying to do this. And sometimes you just can't do it. It becomes a nightmare. But that's the goal. The goal is to try to take the hardest logic and turn it into something simple.
And if anyone's going to try to do any kind of calculation, the best advice that I can give is basically start simple. Do a basic cut in, cut out, and then basically just do simple functions first before you try to attempt something crazy or some kind of Kevin crazy flexible combiner, because he's real good at that.
The worst ones are where you have like three logic statements combined into another one that is, taking those three different logic statements to make a decision for what the fourth one's going to do. Those are the worst.
Go ahead, Kev. What were you going to say?
Well, I moved on to block logic with, just for example, we had to do some stuff just to cut off fans at a walk-in. I think I had 21 blocks just for the simple fact to cut off fans in a walk-in and turn them back on when it got to a certain temperature or time.
Wow.
Not just with Danfoss, but like it's 21 different blocks on this. It was microthermal. 21 different blocks.
I was going to say it's either microthermal or RDM, because RDM has that program with the 650s where you basically write the logic.
Yeah, I mean, if a normal technician had to look at that and troubleshoot it, they'd be almost completely lost.
Absolutely.
They can get difficult, though. I mean, like if you don't know what's linked up to where, you basically have to de-engineer it and basically figure out where do you start.
Yeah, I mean, to be honest with you, when I walk into something like you guys would have created, I sit there and look at the logic statements and I write them out on paper. Because I need to follow a map, especially if you've got two or three that are controlling a fourth one somewhere. I've got to lay that out to get it right in my head to go, okay, is that right? Is that going to work? And then I can work backwards from there and determine, okay, can we change this or can we change that to make it work? That's unfortunately, I'm of that age. I can't think of this shit in my head anymore. I got to write it on paper.
That's my only big complaint about the Danfoss calculation blocks is they're all jumbled and separate. Whereas if it was block logic on a screen, I think block logic on a screen is amazing because it's like troubleshooting a wiring diagram. So I mean, it's a lot easier to troubleshoot, but I mean that's where that calculation blocks get kind of hard, especially if they're split up and it's calculation block 3 and 4. Then all of a sudden it's got 2 in between. Like I saw one the other day, it had 7 in between. It was calculation block number 9. It gets really confusing. You can, like you said, you got to write them down and go through them all.
Yeah. I'm not gonna. I'll never sit here and say we're the easiest to follow on logic statements. I think we do pre-can a lot of things there that kind of eliminate us from doing certain logic statements. I think there are some pre-can things that we have that do that, and also some of our case controller stuff. Like shutting off fans and stuff like that. We have that pre-canned into a case controller where we don't have to develop that logic, but on the occasion where we do, yeah, it's a pain. It's I can tell you honestly sitting here that I've already called, you guys all know Dave Yoder because everybody knows Dave Yoder.
Yeah.
But I can tell you that I've sat here and I've banged my head for an hour or better on a logic statement only to call Dave up and go, Dave, I've got these points and I cannot figure for the life of me how to make this come out the way I want it. And he'll go, oh, it just takes this. And you sit there and going, God, I'm a dumbass.
That's the most that's the most irritating thing in the world, because when someone just basically just schools you in one just fail swoop, where you're like, oh, I'm really stuck on this, and it's something stupid, simple that you're like, shit, I should have thought of that 2 hours ago.
Yeah. It happens to every single one of us. There is no ifs, ands, or buts about it. It happens to every one of us. And sometimes you just got to have an outside set of eyes help you. You get so far, you're so deep into a project, and what do they say? You can't see the forest because of the trees. That's one of those things, man. You're just so far into it that you can't back out and see the big picture. So sometimes you just got to stop and go, dude, help me out. I can't see it. There's something going on here and I don't see the anomaly. So it's good that we all have that extra. Honestly, You know what being a good technician is, and I don't know if you've ever said this before, Brett, or not, or Kevin. It's not knowing all the answers. It's knowing where to find the answers. That's being a good connect. There's nobody out here that knows all the answers. If they do, they're lying to you.
And and Kevin goes through this all the time. Same thing with me. People, Brett knows everything. I don't know. No. I mean, because at one point I have to call someone. I call someone that has more answers than what I have. Right. Same thing with being a service manager. So my service manager said to me one time, he said, my job is to hire people that make me look good. Basically just to make sure that, the ship's sailing. Right.
Yeah. Yeah. Half the time you're just a traffic cop in this world, to be honest with you. You're directing things different directions. And again, that's knowing where to find the information and how to get it the right way. But, I mean, in the long run, what we were talking about communications wise, honest and truly, it boils more down to the basics than anything. And any good refrigeration tech will tell you that too. When you're looking at refrigeration issues, just like we talked about earlier, don't go for the big kill. Go in there looking for the simplest, stupidest thing first, and let yourself develop. And if it's a big kill, you're going to find it. But don't go looking for that big kill, because you're going to look over the fact that, hey, somebody cut this wire, instead of going, oh, I don't have communications, it must be this and it must be that. And a lot of times you'll hear us tell you, hey, don't blame it on the black box. Don't blame it on the magic black box. Look for something else first. It's been working for a long time. Go ahead, Kevin. You got your hand up.
Yeah, I got a question. So this is something maybe you could answer for me. So we've been doing a little more Danfoss here and there. Why is it that randomly, like, sometimes you'll have stores where, like, the boards won't come back online, and then you have to go there, do a rescan, and it's fine. And then it's fine for months, and then randomly you got to go there and rescan everything, and it's fine again.
Well, first off, without seeing it, I'm not going to give you a great answer, but I'm going to give you some possible answers. So just like Brett was talking about earlier, where he had that compactor you said that was acting up every once in a while, you could have anything like that. And it could be as simple as, I've seen this happen, when you get into like HID fixtures where they have that huge like transformer at them, and the transformer's just starting to go bad, and you've got wiring running anywhere near that. It'll throw such a tizzy into some of these communications loops that it can crap out for a while, but when you go look at it, there's no problem. Everything can back online. You have that type of thing that can happen almost anywhere in there. The fact that we're putting all these shields and all this other stuff into it does not make it completely foolproof. And the other thing is, you've got such a mixture in this world, and I don't care whether it's Comtrol, Danfoss, CPC, microthermal, I don't care who it is. You've got electronics that are being mixed with water, refrigeration, cold, heat, electrical noise. There are so many things impinging on that. It'd be hard pressed to tell you what it is. Again, if we threw a scope on it, that would be definitely something that I would look at, would be noise on there. And it could be an intermittent noise, Kevin. I mean, the fact that you're getting it to come back online and not have an issue shown after that kind of points away from, sorry to say it, but it points away from the Danfoss equipment. It almost points that there's something outside acting upon it. Usually, and I'm going to say this, usually if something's going to fail on a Danfoss, it's not going to come back online. It's going to fail. And you're not going to see that intermittent issue like that. The only time that I've ever seen that actually is down kind of in Brett's area there, and it had to do in Texas when you get into the high heat. And some of those older controllers, like the 55 and the early 255s, couldn't take the heat real well. And you'll find that there's racks down there that there's doors hanging open, and they have the controller door hanging open just to get air in there to keep that thing from acting wonky. So there's just too many things, Kevin, to say. You almost got to look at it on a case-by-case basis and try to narrow it down. Obviously, up in the Chicago area, I don't think you got a heat issue up there or anything like that. but look around. I mean, that's all I can tell you is just look around, and you know how this stuff operates. You've been doing it for a while. Look for something obvious. There's something going on. And if you can't find something obviously, go out and get one of these cheap oscilloscopes and throw it on and see if you've got some noise. And like I said, they're I say cheap, and trust me, I'm not making any money off of them because I just buy them off of Amazon like you would. But it's a nice. It doesn't have to be a $5,000 oscilloscope for you to find problems.
See, that's why I never bought one.
Yeah, Brian, you should probably post when we post this podcast. You should probably post the link to that oscilloscope on there.
Yeah,
if it's that cheap, I mean, I would. Well, when I say I would buy it, I mean the company would buy it. I mean, to use as that, but I mean that's something that could be used for multiple things, multiple control systems. And if it's really that cheap, I mean, most oscilloscopes I've seen have been like $1,000 if for like starting. If I think it's like that cheap, I mean that's great.
And you called it I was trying to spell it, but I spell phonetically. I tried doing periscope.
Picoscope. Pico scope. And I'm tooling around my computer right now to pull Amazon up quick. Picoscope.
If I pulled Amazon right now, it would probably crash a whole.
Yeah, the first one that comes up is like $1,300. You find me the good Amazon one and give me the part number. Oh, wait a minute, Picoscope.
A 2205A, 2-channel, 25 megahertz, $245.
There's a 2204 Picoscope, 2-channel. It's only $150.
Yeah, just look for the ones because see how that says without probes though.
Yeah.
So just find one of them that actually has the probes with it. I mean, you're $300 maybe tops. It does not have to be, electronic grade. You're not engineering it. You're looking for noise.
Yeah.
So that's why I say those are for a toolbox technician. It's a great Picoscope to be able to do that.
And for how much you're going to end up saving in the long run because you're not going to have to be out there 20 times.
Yeah. I mean, obviously, this isn't. You're not going to go out every time and go, I'm going to throw the scope on and see if I got noise on there. You're still going to do your due diligence and look for your connections. Are they screwed down? Do I have a termination resistor on? Is it the right termination resistor? That's another lovely one that we've thrown to you. How many times have you gotten a combo board from us and you get that nice little pack of resistors and go, hey, I'm going to keep them because I might need a termination resistor, only to find out that they're 47 or 51 ohms. And if you throw those on, it throws that network into a tizzy where it looks like freaking lights going on a space shuttle.
Nice. Kevin, do you have any more questions for Brian?
No, I think that's it for right now. I'd love to get him back on and start go over some programming and more so the 800 series controller one of these days.
Absolutely. Brian, you be down for that?
One of the three of us will more than gladly help you out.
All right. Well, Brian,
we got three resources.
What's that?
I said we got 3 good resources. So I'll do it. I don't have any problem doing it at this point. Honestly, you and I talked the other day and I was like, I don't know if I want to do this, but I don't think I look like too much of an idiot today.
Oh, no, dude, you did amazing. I appreciate it, man. But hey, guys, thanks for listening again, and we'll catch you next time. Thanks.
Have a nice night, guys.
Thanks, Brian.
See ya. Yep.